Next, we will take a deeper look at the relation between the sample size and the margin of error. So let's take another look at the margin of error formula. Since sigma is a constant and cannot be changed, a higher accuracy or smaller margin of error can be achieved by increasing alpha and sacrificing the confidence, or by increasing the sample size without any sacrifices. If we want to construct a 1 minus alpha times 100% confidence interval with the margin of error no more than e sub 0, how big we should choose the sample size? Since the margin of error can be greater than e sub 0, we have the following inequality. By isolating the sample size, we may obtain the following solution. This means that to find the required sample size, we need to know alpha, sigma, and the bound on the margin of error, e sub 0. For example, let's find the sample size required to construct a 90% confidence interval with the margin of error no more than 0.5 if the population standard deviation is 2. To apply the formula, we must know E0, the bound for the margin of error, sigma, the population standard deviation, and z sub alpha over 2, the critical value. From the problem, we know that the bound for the margin of error is 0.5 and the population standard deviation is 2. For a confidence level of 90%, alpha must be equal to 0.1. Therefore, z sub alpha over 2 is z sub 0.05, which is equal to 1.65. Finally, we can plug in the numbers into the formula and obtain the required sample size. Remember that in such problems, we always round the sample size up. We just learned how to compute the sample size to achieve a desired accuracy when constructing a confidence interval for the unknown population mean with non-population standard deviation using the average of a random sample.